Hello and welcome everyone. Today I'm going to present our work entitled NodeGIS, a container-based WebGIS application development tool. The authors are Matheus Queiroz Cunha and Cláudio de Souza Batista. This work was conducted by the Information Systems Laboratory at the Federal University of Campina Grande. My name is Matheus Queiroz Cunha. I'm a master's student in computer science at the Federal University of Campina Grande, located in northeast region of Brazil. I'm also a researcher and a software developer at the Information Systems Laboratory. As for topics of research interest, I cite geoprocessing, geographic information systems, and natural language processing. Associated with the ongoing enhancement of technology, spatial information can be vastly found among the various solutions we use on a day-to-day basis. That much data aggregates information and relies on geographical information systems to be represented accordingly. That opens up the emergence of several commercial and free tools and APIs that promote the development of GIS, especially WebGIS. There are highly capable solutions available, such as GeoServer, MapServer, QGIS Server, ArcGIS Server, and Mapbox. Although highly capable, they contain different complexity and requirements, many times requiring specific skills from the user in different technologies. Another downside is the prices of some commercial solutions, which can be very high for commercial and even educational purposes. These can be limiting factors when it comes to developing a WebGIS application, given that users need to address their domain-specific challenges associated with the complexity of GIS tools. In face of the presented context, our motivation relies on the fact that there is a need for a solution that simplifies the process of building WebGIS applications. To address the motivation previously stated, we propose NodeGIS, a tool that simplifies the process of developing and deploying WebGIS applications by providing a graphical interface that does not require code writing or a complex server configuration. NodeGIS aims to bring a desktop GIS experience to a WebGIS application. It is open source and follows REST and container-based architectures. NodeGIS offers several features that simplify the process of developing and deploying WebGIS applications. These features include adding of vector layers, customization of map layers, overlay, zooming, panning, tooltip, conventional and spatial queries, construction of thematic maps, as shown in the image on the left, interactive spatial queries on the map, search for map features, use of multiple spatial databases, and visualization of data in table format. NodeGIS is based on a REST architecture segmented into the front-end and back-end, associated with one or more spatial relational databases. The front-end is responsible for rendering the user interface and communicating with the back-end through RESTful APIs. React, Leaflet, Mobax, and Axios are the main libraries used. Concerning the backend, it is responsible for processing requests from the frontend, interacting with spatial databases, and returning responses to the frontend, using the Express library associated with an SQLite instance for application data management, along with the various Node.js database clients. To provide versatility and possibility of choice to the user, NodeGIS has compatibility with different spatial relational database and management systems, namely PostgreSQL with its PostGIS extension, MySQL, MariaDB, SQLite with its Spatialite extension, and CockroachDB. NodeGIS uses Docker containers to deploy the application. The deployment consists of two images, one for the frontend and another for the backend, in addition to a PostgreSQL container that stores spatial data. The architecture of NodeGIS is designed to facilitate the development and deployment of WebGIS applications by providing a container-based solution that simplifies server configuration and makes it easy to deploy applications on different platforms. Also, along with the application, we provide configuration scripts that also help to make the experience of using NodeGIS as simple as possible. Now we are going to see some examples of NodeGIS features. Let's start with adding a new vector layer. When selecting the Add option in the menu, followed by Vector Layer, a dialog analogous to the one shown in the figure is displayed. Users can then select the database table that originates the data, type the name of the new layer being added, and also select the geographic column of the previously selected table that will be displayed on the map. Users can also add a tooltip to each layer feature and configure the layer style, changing stroke and filling colors as well as the opacity of the elements and the stroke width. Users can also apply a thematic style, using the data associated with the map features to create conditions to apply different styles. Another main feature of NodeGIS is the user interface spatial query. Spatial queries are based on map feature selection and can be accessed in the menu using the Spatial Query selector, followed by the From Selection option. This feature allows the user to select the desired operation and the parameters needed to carry it out, feature or layers. Users can execute queries resulting in geometries such as the buffer operation or values such as the distance operation, as shown in the figure. It is also possible to record the result of spatial queries in new tables in the database, thus possibly reusing them in new queries or saving them as the default visualization of NodeGIS. Now we see an example of how feature selection for a spatial query works. The selected features are highlighted when selected and added to the query. When users conclude the selection, they can click on Save Selection to proceed to the query. Showing another example of spatial query using the same interface as shown before, the displayed image shows a 20 km buffer operation applied to the geometry of Campina Grande municipality, located in Paraíba, Brazil. Despite NodeGIS' focus on simplicity, users can also write complex queries using the native SQL, not limiting those who already have the knowledge and want to display their data using NodeGIS. Our application allows users to create WebGIS applications in a facilitated way, all using graphic interface, but not limited to, in the case of advanced users. Along with an easy-to-use interface, NodeGIS brings a desktop GIS experience to a WebGIS application. Also, when using NodeGIS, users can focus on their domain-specific challenges instead of having to deal with deployment or application usage issues. Also, NodeGIS can be used to teach GIS, offering a friendly first experience without requiring software installation from students. In future work, we will incorporate new and essential features into NodeGIS platform, including table editing, data exportation, and multimedia data association that consists of associating images and videos with map features. Furthermore, we also plan to include new complex features such as 3D visualizations, point cloud, and raster support. This is it for today. Thank you for your attention.